morning, everybody. Can you hear me? Yeah, great. It's wonderful to be here. The first person I met when I arrived this morning was Kirsten, who directed me to a parking spot, and she was clearly in charge. And then I met Paul, and he was clearly in charge, and I met Felix, and he's in charge. This is an amazing place. It's a multifaceted ministry place, and it's good to be here with you this morning and to be able to share a little bit of my journey and to talk about the things that are most central to that journey. The journey into understanding this beautiful planet has been part of my life that we live on. The result of the acts of God's creation has been a lifelong quest. In fact, I was a scientist before I was a Christian. I was brought up in the Presbyterian tradition in South Africa, born in Durban on the East Coast, and was sent off to Sunday school. I noticed when I was about 6, having been in Sunday school for a few years, that my mum would drop us off at Sunday school, and then she would drive away back home. Home wasn't too far from the church, and she would drop us off and disappear back up the road. And I was quite an inquisitive young person and said to her, "Mum, why do you just drop us off at church and then leave?" She was a medical doctor, a psychiatrist. She was actually in the first women's intake into psychiatry, into medicine at the University of Witwatersrand in Johannesburg in South Africa. 3 women that year, 147 men. And she came top of her class at the end of her medical studies, so she is a pretty bright lady. And so she said to me, "Well, actually, I'm something called an atheist. I don't believe in God." But my grandmother was a very, very strong Christian, and out of sort of respect to my grandmother, my mum was taking us off to church every Sunday. So I said, "Well, that's really interesting. I think I'm going to be an atheist as well because I didn't enjoy Sunday school." And so I declared atheism at the age of 6 to 7 years old, and stopped going to Sunday school, basically, which was a great disappointment to my grandmother, but a kind of a relief, I guess, to my mum, who didn't have to get up early on Sunday mornings to take us off to. So I was a dedicated and committed atheist for a number of years until I came to faith. But a couple of years later, I went off to boarding school. Now, the reason I went off to boarding school is my dad had absconded. He had left us. My parents were divorced, and part of the divorce settlement was that he was not allowed to see us again. So I saw my dad once after the divorce settlement, and the moment that I saw him, my mum's secretary was phoning the police to make sure that he was removed from seeing us. So that was the last time I saw him, and I don't know what happened to him ultimately. So it was pretty tough not to have a dad who was reliable. But my mum was a great mum, and she brought us up and looked after us. But that meant we had to go to boarding school because she had to work, and there was no way to really look after us without us going to boarding school. So I was 6.5 years old when I went off to boarding school. And at the end of my first year of boarding school, I got this book called Science Can Be Fun. And that was the start of my journey in science in essentially the 3rd year at school. And this book, written by Munro Leaf, became almost like a Bible for me. And it starts off, the very first words in this book say, "Science is really knowing the truth about the world we live in." That's the opening sentence of this book. This is going to tell you the truth about the world we live in. And I've still got it. As you can see, it had a big impact on me. On the last page of the book, it talks about how atomic energy is going to make electricity so cheap that we won't have to pay for it anymore. So it's an interesting book. It starts looking for the truth and it ends up confused about the future. And so it symbolizes in many ways my journey in science has been longer than my journey in faith. And so right from the beginning of that journey, I wanted to understand how we could put science to work. I like discovering things and understanding things, but can we put science to work? Can we make science make this a better place to live. And most of my studies and my career in science has either been myself trying to make things that can make things better, or working and growing people who can make things better. And the greatest joy for me is to see scientists move from a kind of a knowledge basis to a practical application basis. And that's really been what my career has been all about. So I was keenly aware as I went through junior school and into high school that I probably would end up having a career in science. And that's proven to be true, and it's proven to be a lifelong mission. But you know, when I got to senior school, I was really challenged. I was thinking through all sorts of things as you do as a young teenager, and I realized that there were some fundamental things that I didn't understand really well. Now, fortunately, my mum sent me to Christian schools. So my first boarding school was a Christian school. My second boarding school was a Christian school, but it was non-denominational. So they didn't have a chaplain at the time, and they used to bring in different preachers every week. We used to go to chapel every day. It was meant to be a big burden. I used to quite enjoy it. I was in the choir, I used to sing loudly. But basically, there were 3 Sundays where we had 3 different visiting preachers who really challenged me to think about what they were preaching about, which is a bit unusual. There were quite a lot of boring preachers, but 3 Sundays in a row to get really challenging sermons it really went into my heart. And so the Wednesday morning was in the period around Easter. The reading was the reading about Thomas when he encounters Christ after his resurrection. And I remember having been thinking about all of this stuff. There were 2 or 3 recognizable Christians in the school who kind of stood out for being Christians. The majority, the rest of us, were functionally atheist or agnostic. And as that reading was read that morning, it kind of struck me that there was a deep, deep reality in Thomas's experience that was recorded in John's Gospel. And I decided to take a bit of a leap, and I said, I'm going to pray that same prayer. If I can see what has happened here, and I can see what Thomas has done, putting his faith into Jesus, I'm going to do the same thing and call him my Lord and my God. I did that very quietly in the chapel, and then I made a terrible mistake. I went out and I told my mates that I'd become a Christian. They weren't Christians. But they kept me honest. They said, if you're a Christian, you've got to read the Bible. And so you need to be reading the Bible regularly. And you need to be meeting with other Christians. So I looked around the school, and I found that the only regular meeting of Christians was the Catholic kids. They used to bring a brother from the seminary, which is just down the road, and the brother would give them a Bible study every Wednesday at 6 o'clock in the evening. You could get off prep for that. That was really cool. So I went and spoke to this Christian brother and said to him, look, I don't think I'm a Catholic. I come out of the Presbyterian tradition. I've just become a Christian. Are you prepared to help me be a Protestant Christian even though you're a Catholic? So I was quite a feisty young person. And he agreed to do that, which was a great act of grace on his part. As he would teach the guys, and I'd listen to the sort of catechism class, and then afterwards he'd say, there's a couple of things a bit different about Protestants. And so as an act of grace, my first set of meetings as a Christian was with a Catholic brother who graciously taught me the elements of the faith. So I've always taken a pretty generous approach to the church. You can find people of faith in the church in all sorts of places, you know, diamonds in the rough, if you will, right? And that's the beginning of my faith. And then I had to spend years reconciling it with my science and coming to but ultimately I saw that the acts by which Jesus brought me to him were the acts that reinforced the need for me to do my earlier calling, which is to be a scientist who could actually bring both my faith and my science into a living reality of having an impact on this beautiful universe that God has created by using scientific knowledge to make things better for people. So very simply, that is the beginning of the journey. It took me till my late 30s to overcome some of the problems that arose from the disappearance of my father. So I can tell you now, losing a dad early and in a crazy way can have a big impact. It took me a long time to come to terms with that. So not everything got sorted out the day that I became a Christian. There are probably still some things that God is working on in my life that have to be kind of wrestled with and so on. So the Christian walk is a tough one, but it's worth doing. When you come into a relationship with Jesus, the greatest possibility, the greatest thing that happens is that you are loved. And to be loved with an everlasting love is the redeeming thing. It's the love that ultimately washes away the sin. It's the love that makes you have the possibility of being new. And that's what animates me really as a Christian, is not being certain of a whole lot of dogmatic truths, but to be certain that in Jesus I am loved and that his love has set me free to know him. It had consequences. One of the consequences was I was living in a divided society. I was chatting to Nico earlier, who knows this, the history in South Africa. And I came out of a political tradition that my mum was involved in, of really not supporting apartheid. And as I was at school, had a very wise headmaster, there was a moment when I had to register for military service. And I went to spoke to him. He was a Christian. And I said, look, I'm not sure if I can register for military services when I was 16 years old, because I think this country is basically politically organized against a really bad principle. He said, look, there are many things you have to work out, but register anyway. So I registered. Eventually, one of the reasons I got a PhD was to kind of avoid military service. I just kept studying, right, to see how we could deal with it. But in the early 80s, I finally got my PhD, and I had to then write to the military, and I wrote them a letter saying that I wasn't going to serve. And nothing much happened for about 6 or 8 months, and then the MPs arrived on my doorstep. I told them where I was. I wasn't trying to hide away. And they came to arrest me. And they kind of took me to the place where they laid the charge, and then they let me go because I promised that wherever the trial was, I would arrive on the day. They didn't need to keep me in the detention barracks. And so I went through, as a Christian pacifist, a trial. And so it was a remarkable set of circumstances. I was expecting to be in jail for at least 2 years. But we found out later that the colonel who was in charge of the court-martial wasn't very happy with putting people in jail. So he gave me a sentence that was the same length as his residual service in the military. He had 4 months to go. And he gave me a sentence that was the same length as his time to go before he left the military. Now, I told them that if they put me in the military detention barracks, that I wouldn't eat the food or drink the water or do anything. So they were a bit worried about that. So they had found a route by which they could put me into civilian jail. And so we had to wait for the civilian authorities to approve the court-martial sentence of 4 months. Well, that took them 4 months and 3 days. They lost the paperwork, and I had the paperwork, so I had to give them back the paperwork so they could finish sentencing me. But it turned out that the colonel had actually written into the trial document that my sentence started on the day that he made the conviction. And so 4 months and 3 days, my sentence had expired. And so when I got to the door of the jail, Pollsmoor Prison in Cape Town, they wouldn't let me in because the sentence had expired. I consider that an act of grace. I wouldn't have been very good in jail. It would have been really difficult. And so, in a sense, the Christians around me at the time, I remember Philip Lefevre, who became an Anglican bishop, was a great mentor to me when I was at university. He came and spoke on my character at the court-martial. And I remember as we came out, and everybody was rejoicing that I only got 4 months, he gathered everybody into a group. He said, well, now we're going to pray that Adi doesn't go to jail. Everybody laughed at him. But so that was a remarkable set of occurrences. It did mean that when I came to Australia that I had to declare that I had a criminal record. And so I'm one of the few people who came not on a boat but on a plane who met all of the criteria of being a good Australian, which is to have a criminal record, of course. Another remarkable thing is that in the post-apartheid era now, they've gone through all of the old cases and that sentence has been expunged. So I no longer even have that against my name. Now, why do I tell you this story? I tell you this story because to me, All the moments of our lives are in God's hands, whether we know that or not, or whether we trust him for that or not. We are in his hands, and good or bad, and not all of it's been good, as I've indicated with my dad and so on, and that was a tough thing to kind of work through. Good or bad, being in Jesus is better than not being in Jesus. But I wanted to tell you something beautiful about science, because the other part of me is about the beauty of science. I wonder whether you ever think about gold. You think about gold? Heavy metal. It's heavier than lead. We often think that lead is heavy, but lead looks heavy, doesn't it? Gold looks kind of light. You know, it's a very different sort of a metal. It's nearly twice as dense as lead. Have you ever wondered why gold is the color that it is? You know, most of the metals in that part of the periodic table are silver. Any metal that is silver basically has no color. That's what a colorless metal looks like. It looks like silver. Because it's not doing anything with the light. The light kind of bounces off it, and it's white light, so it looks silver, right? So when we talk about the silvery light of morning, we're talking exactly about what a colorless metal looks like. But as you go down through that period, straight after platinum, which is a silvery metal, comes gold, which is yellow. And why is it yellow? Well, gold is really interesting because it's just at a place in the periodic table where the sixth ring of electrons, you know, we often think about these rings of electrons, has got to the point where it's just about filled up. And as a result of that, gold has a very special property that all the electrons around gold, which you think of as being in rings, the little electrons in that outer ring in gold, because of the way those rings fill up, move faster than any other electrons in any other atom in the whole periodic table. And because they move faster, they move almost at a relativistic speed, you know, close to the speed of light. That means you get what you call relativistic compression, which actually reduces the size of those rings. And in fact, atoms really don't have rings in the way that we think about it. They just have probabilities of being places. So those outside electrons are actually closer to the center of the atom than you would imagine. In fact, they're just about as close as the first ring of electrons. And because they're going really fast, it changes the energy of those electrons in a way that it moves it out of the changes in the energy of the electrons, moves from the ultraviolet region into the color spectrum and absorbs blue light. And because it absorbs the blue light, gold is yellow, which is the complementary color of... isn't that amazing? Yeah. Who would have thought it? Right? Gold, silver, and precious stones. That God has created this one element that has the characteristic that it has color, but also because those outer electrons, which are the things that do the chemistry and react with everything, are so close to the nucleus, you can't even do anything with gold to make it tarnish. So gold doesn't tarnish because of this property of these electrons, bringing them right in close to the nucleus. Now, you didn't know that till this morning. Did anybody know that about gold? Don't you find that beautiful? Don't you think it's remarkable that the periodic table... Now, you know platinum, gold, what's next to gold? This really resilient, unable to react with anything metal. The next one's mercury. Wow. You add one electron, and it goes from being a high-temperature metal. Platinum's one of the highest temperature ones, by the way. Gold, you can melt it at a reasonable temperature. Next one's mercury. It's a liquid at room temperature. You add one electron, and everything changes. The properties change. It's still silvery because that's all happening in the ultraviolet piece, right? Do you know that there's an academic in New Zealand who 2 years ago, by doing very careful theoretical calculations using the equations, the mathematics that we developed to understand mercury, finally was able to, using that mathematics, predict exactly what temperature mercury becomes a liquid. They started with mathematics to predict that temperature. Of course, we could measure that temperature. We could just do the experiment. But science now knows so much about gold and mercury that they can do these very precise calculations. That's the beauty of science. One of the most important things that's happening in science at the moment, and ANSTO does work on this with researchers from the Garvan Institute, for example, is we're starting to understand our brains. And the previous head of the Garvard Institute came to give a talk at ANSTO, and he said a remarkable thing. He said, it is possible that every neuron in our head has got a slightly different genetic sequence. Now, if I tell you that there's more than 13 trillion connections in your head, I know that could hurt your head, right? Okay, so you've got 13 trillion connections, and each of those neurons that is making those connections is an individual neuron that is different to all of the others. Does that make you feel that you're wonderfully made? Okay, don't mess with those neurons too much, right? But it is possible that every neuron in our brains is unique, which means that if each of those is unique and it adds up to who we are, that means that we are uniquely made. And the Bible says that we are made in God's image. And so for me, the journey of science is, first of all, to kind of understand that stuff, but then to use that to think about how do we deal with diseases of the neurons. How do we make sure that when things are going wrong in this fallen, broken world that we're living in, that we can make things better? And we can do that with a life of faith to bring hope in a broken and an uncertain world. But we can also bring hope through the deep understanding, the deep texture of science, the deep knowledge that we can get from understanding what Francis Bacon called the book of nature. So we have the book of nature, but we've also got the Bible. Now, I just wanted to bring the Bible in because this book had a big impact on me. My mum didn't finish life as an atheist. Late in her life, she became a Christian. And one of the things she did, I think, out of reverence to her mum, who was an amazing woman in her own right, also a single parent, by the way. So I come out of 2 generations of single parents, great women who brought the life into my body and the life of faith ultimately. And my mum had bought this Bible. It's called the New English Bible. It was a new translation. And so she'd heard about this new translation. She'd bought it. She put it in the bookcase in our study. Now, I knew my mum was an atheist, so I assumed when I was getting interested in Christian faith that she wouldn't be reading this book. So I nicked it to take to boarding school. And I read it, and it's got all sorts of things that I've written in it at different times, and it's scribbled on and so on. And this was the Bible that I used after I became a Christian. And I remember getting back that June, going back home, and my mum says, I can't find the Bible I bought. And I had to admit that I'd stolen it. So she said that I could keep it, and she bought another copy and continued to work and study the Bible. And right in the front here, I went and listened to a sermon, and one of the sermons I preached was about Hebrews 13, verse 5. And the preacher used these words. He was trying to explain how intense this verse is and how deeply it's written. I will never, never, know how leave you. That's Hebrew 13, verse 5b. To me, the desolation of losing my father and watching him walk across the tarmac to get on that aeroplane, and then seeing him briefly while the police were being called was one of the most devastating things that could have ever happened to me. But I met a heavenly Father who through Jesus has brought me back into a living relationship with a true Father. And this word says, I will never, never, know how leave you. I will not desert you. I'll never leave you alone. And that has turned out to be true in my life. So I'll stop there and take some questions and comments. Thank you.
Thank you, Aidan. Who's our runner? All right, thank you. So this is a good opportunity. Adi, I really want to thank you for sharing such deep personal stuff as well as the science around gold and what have you. Very interesting. So the Q&A, you can ask scientific stuff, or you can ask him about his life, particularly the tough times in apartheid and without a father and all the rest of it. So please, put your hand up and Rick will give you a microphone.
You can ask about ANSTO and the beautiful...
Yeah.
Oh, that, by the way, is a picture looking down into the pool of the reactor. And that middle bit is called the core of the reactor, and that's looking right into the core. You see it's got a blue colour? That blue color is because the electrons that are formed in those nuclear reactions, they're not the ones around like gold, they come out of the nucleus when the nuclear reaction happens. You get new electrons. They're going too fast. They're going essentially at the speed of light. And then they find out they're in water. And because they're in water, they have to give up some energy. And they give up literally blue light, Cherenkov radiation. I call it the police force for the electrons out of the nucleus. Because they're going too fast, the blue light comes and arrests them. And that's literally what's happening. Yeah.
Adi or Mr. Paterson or whichever.
I can't see where the microphone holder is. Oh, there you are. Yep.
Sorry, I was just going to ask you to briefly describe what goes on at ANSTO, if I may.
Yeah, sure. So ANSTO, the main campus is at Lucas Heights, which is the last place before Sydney stops being Sydney, up in the hills there. It's the top corner of the Shire. And we don't have a bus stop there yet, but I'm negotiating for the bus stop. The last bus stop in the Shire is going to be ANSTO. So ANSTO operates the beautiful Opal reactor. That reactor's job is to produce nuclear medicines. So we produce about 9 to 11 million doses of nuclear medicine every year that are used in Australia and around the world. And that has a positive impact on the diagnosis of disease. We also make other isotopes that are used to treat disease. And in fact, I just came back from a conference in San Francisco where we're talking about some real new breakthroughs in nuclear medicine to attack some cancers that are really, really difficult to treat. And one of those isotopes is called lutetium-177. There will be an exam afterwards. You have to remember all of this, right? But lutetium-177 is unique in that if you can take it to where the cancer is happening, it lets out one of those electrons that I'm talking about when it decays. And those electrons are very high energy, and they go and they smash the DNA of the cancer. And you can treat cancer by taking a nuclear isotope and putting it in the body. So that's one of the things we do. We support other researchers. So we run the synchrotron down in Melbourne. About 6,000 researchers a year benefit from the X-rays that we produce, and we use those X-rays to do science. We use the neutrons from the reactor to do the same sort of science, but using neutrons. So we've got a neutron source and an X-ray source. And the best science, all of modern biology is based on using those X-rays or using those neutrons to understand how we are put together and how we are made. So we do a lot of biological sciences, do a lot of environmental sciences. So isotopes decay. So if you, for example, have got some groundwater in Rocknest Island off the WA coast, and you are putting a bore down and you're getting the water out to use it as your water source, you want to know how old that water is, because if it's very old water and it's not being replenished, you're going to use it up quite quickly. So all water has got isotopes in it, and if it's very old water, the signature of those isotopes will be different to if it's very young water, okay? And we can use these very precise nuclear techniques, both on radioisotopes and stable isotopes, to understand the age of water. And so we do a lot of work around Australia because we're a water-stressed country, understanding things like that. We can also, for example, you know about stalagmites and stalactites in cave? So you know how they form. It's drips of water, right? You think, well, if it's water, how do they form? Well, there's a little bit of calcium and other elements in that, and it kind of drops onto the stalactite, and it gradually builds up layers as the water drops come in. Now, if you think about it, if that water is coming from thunderstorms that are coming off the ocean, again, say in WA, that stalactite is a memory chip of every storm that has happened over the time that stalactite has grown. Isn't that amazing? It's like memory chip of every storm. And because cold water has got more heavy oxygen in it than warmer water, we can study those two different oxygen isotopes to work out whether that storm came from the Southern Ocean or whether it came from the Indian Ocean. And so you can actually know where the storms are coming from 950 years ago. You can know whether that was a cold water storm or a warm water storm. And in addition, with other isotopes, you can work out how often the storms are happening, and you can work out how long the droughts are. Isn't that amazing? So that's what nuclear scientists do, right? And I can tell you now that the longest drought that we've been able to find over with that, and obviously there's a bit of rain in between, but not a lot, In Western Australia, there's about 150 to 200 years drought. So if you think we're having bad drought when it's 5 years, you can imagine having 150 years of drought. So is the climate changing? The climate's always been changing, and it is a pretty dynamic system, but we've got these stalactites and stalagmites. We can do the same thing with corals, for example, and understand stuff about the reef and so on. So ANSTO is really a place where people come to use the equipment that we have got, and our own scientists do the same sort of thing, to answer some of the deep and profound questions that challenge us, and then to come up with solutions to that. And that's why it's such a wonderful place to work. So there are new drugs which have been developed at the Walter and Eliza Hall Institute down in Melbourne, which would never have been discovered if we didn't have a synchrotron in Melbourne. It's my great privilege to have been able to take the synchrotron, which is having a bad time and running out of money. ANSTO took over the operations a number of years ago, and then I was able to persuade the federal government to give me $520 million to run it for 10 years in a predictable way, so we could do that sort of science. So that's my job, is really looking for money and making it predictable.
Pass that round later.
Yeah, so that's the excitement of being at ANSTO, is to mobilize the people to help answer those questions, to bring hope to people who've got diseases, to understand our planet and its deep history, and to do that in a way that adds value to our society. That's what ANSTO does. I hope that's helpful. Yeah. A man with a mic, yeah.
Yeah, I got it here. Yeah, there's a multitude of questions, scientific questions I could ask you, but I'll confine myself to two. One is, with gold especially, where the electrons spinning around at that speed, how come they don't bash into each other?
Yep.
And the other one is, when a light leaves the Earth at 186,000 miles a second, forever, how does it keep going forever and ever?
Okay, that's really two very good and profound questions. So why don't the electrons bash into each other? Well, we've been trying for decades and decades to measure the cross-section of the electron, saying how big it is. And I have to give you this bad news, that as long as we've tried to measure the cross-section of the electron, it seems to be a point source. So the thing that keeps them apart is it's got a negative charge, so if it comes close to another one that's got a negative charge, they're going to repel each other. But at the moment, we don't know the size of the electron because we still haven't been able to do a precise enough. So it looks like a point charge source. So electrons are leptons. It's a characteristic of the deeper understanding. And they are point charges, and they've got a negative charge, so they don't bump into each other. Now, the real question is, why don't they fall into the nucleus, right? And the reason for that is that the way that quantum physics is organized is that no matter how fast they move, they don't actually get pulled into the nucleus because of their own self-energy that they have because they're moving around. That's quite a profound and weird thing. In fact, I was reading about that this week because it's one of the things I can't quite get my head around, is why is it all not just collapsing into the nucleus? But it turns out as soon as they've got some speed and some momentum, they've got some control over their density. So if you can make electrons go really, really slowly, they lose control of their destiny. Whereas if they're going fast enough, then they have effectively more mass than you would expect them to have. Yeah. So it's really cool to understand that. Now, the other thing is light. So light is photons. Electrons got mass. The photon has no mass. Okay, so a photon, a little pulse of light, has got no weight. So when light starts moving, there isn't much that can stop it. But actually, you can slow photons down. And one of the really interesting experiments, they do these at ANU, is to try to get the photon to sort of almost stop, because then you've got something that doesn't weigh anything, but has got properties, right? So how cool is that? So you kind of get the photons to go really, really slowly and eventually just about stop. And that's right at the extreme edge of physics at the moment. So your question is a profound question. What is it about these photons that when you just let them loose, they keep going? And in fact, Einstein sorted out a lot of those issues by really understanding the difference between photons and other types of matter. But the whole of nuclear physics and particle physics and the Large Hadron Collider, where we had a good relationship with people at CERN, for example, and we visit and send Australians over there regularly. That's all about understanding those deep properties of matter. And the big thing that this 27-mile 27 kilometer ring does is take protons and smash them together. They say it's like taking two aircraft and smashing them together, looking at the pieces to reconstruct the aircraft, right? So that's what physics is all about. And to me, one of the profound things about the more and more we discover about physics, we're finding out two things. It's beautiful and it's systematic and it's complicated, but it's ultimately ordered and clearly structured in a way that we can understand it, which is remarkable. If you think that these trillions of neurons in our brains can actually connect to the very created universe that we're living in. And we seem to be one of the very few societies anywhere that we can detect that has that capability. And I think that is part of the grace of God, is that He gives us the capacity to understand the world that we live in a very deep and profound way. So you've asked a really tough question that I can only partially answer. How did I become the CEO of ANSTO? Well, I was in South Africa. I spent most of my life in an organization a little bit like the CSIRO. And then after apartheid, I was invited to help transform the system to make it accessible to more people in the society. So I've worked in government for a number of years. And then I joined a company called the Pebble Bed Company, which is developing a nuclear reactor of a particular type. They're building one in China at the moment. And I was enjoying it, but I wasn't having as much fun as I thought I could have. And somebody phoned me up and said, their job at ANSTO has been advertised and it's a global search. I thought, oh, let me give it a try. I'd never been to Australia. I understood it was in the Southern Hemisphere, but that's about all I knew about Australia. And so I applied for the job. I had a telephone interview and then a video interview with the chairman at the time, who was Ziggy Switkowski, who is quite well known in Australia. They brought me out and I had 8 interviews in 3 days. Wow. All right, I didn't sleep very much. And then they offered me the job. And I really, I wanted it to be a job that I could do. And so I said to Ziggy, it's really important that I will only come and take this job if the board is unanimous about my appointment. And that proved to be the case. So I then got the letter, sorted it out, brought my family across in January so that they could have a look at the place. They weren't terrified. My son got food poisoning. That was very helpful. And then I've been here since March 2009. It's been an absolute privilege to be associated with ANSTO. So the ANSTO of March 2009 had 920 people. We've now got 1,340 people. That was part of my job, is to grow it. And I'm hoping to do about another 3 and a bit years. Then I'll be 65 years old. That'll put me out to pasture unless God intervenes in some way in between. And so, yeah, so that's my journey is to Australia. I came here to look for a job, and I found a home. Kath and I have been extremely happy here. And we worship at Gymea Anglican. We found a network of beautiful friendships and so on. So it's been an interesting journey. I mean, normally kids leave their parents. In our particular case, the parents left the kids, which they found quite challenging. But that was my journey to Australia, and it's been good. Yeah, that's all.
Thank you. Particularly interesting. Thank you very much for your presentation. But probably not as complex as the earlier questions, but nevertheless, I suppose some people are curious about the answer. Our Australian Commonwealth government are buying $35 billion worth of submarines, nuclear, from France. And they're going to spend another $15 billion to modify them.
Yeah.
Do you think this modification is a good idea and worthwhile?
So I'm an employee of the Commonwealth, and I can answer some of those bits in general terms. But ultimately, interestingly, I'm the only civil servant at ANSTO according to the Act. And according to the regulations, I'm a principal executive officer. I'm a civil servant. Everybody who works at ANSTO works for me. They're not mentioned in the Act. Employees are not mentioned in the Act, just the CEO. So I'm a civil servant. The people at ANSTO are not civil servants. So I just thought I'd correct that impression. But as a civil servant, I could not answer your question as to whether it's a good or a bad thing or whatever, but I can confirm that the French attack submarine, which is the basis on which Australia is going to provide the new submarines, is indeed a nuclear submarine. And I can tell you that Brazil is buying 4 of those same submarines. And the first 3, they're also going to do the same thing, is de-scope it, put in a gas turbine or 2 and a bunch of batteries, and they will run those with gas turbines and batteries. The reason that you don't just run the gas turbine is it's got to be really, really quiet. You know, if you want to be a submarine, you don't want to be making a lot of noise, so they use the batteries when they're in silent mode, and they use the gas turbine to charge up the batteries. And so that's the design that is going to be very similar to the design in Australia. The 4th one in Brazil, they're going to cut a hole in the side, and Brazil has developed a nuclear reactor that can go into a submarine, and their 4th one will be a nuclear submarine. So I don't know all of the reasons, but it's not unusual for countries to de-scope nuclear submarines, because Brazil is doing it, and we're choosing to do that as well. It'll be interesting to be here for the next 40 years and watch that program. See what sort of a program it is. Yep.
Haven't they already made a nuclear battery?
Oh, nuclear batteries. Now you're talking. I've just been at a conference where people are talking about nuclear batteries. So what's a nuclear battery? So a nuclear power plant, this is not a nuclear power plant. This is a 20 megawatt class reactor. So how big is 20 megawatts? Do you know the old kettles that we used to have before we got the metal ones? They took about a kilowatt of electricity. So a kilowatt's 1,000, a megawatt's is a million, all right? So 20 megawatts is 20,000 old kettles in a bar fridge. All right, so if you can imagine taking all of those 20,000 kettles and putting them into a bar fridge, that's the energy density that you can see there on the screen. There's a lot of energy stored in there. And that's, we keep that at 40 degrees. We put a lot of cooling water through that so we keep the temperature down. In a power reactor, what you do is you take a lot more uranium. Instead of having about 2 kilograms of fissile uranium, you now have 2 tons, and you put it into a big core, and then you let it get hot. And you take the differential temperature of how much heat you produce to produce electricity. The production of electricity, until fairly recently, has been all about temperature difference, right? The bigger the temperature difference, the more electricity you can get out of it. So that's what nuclear reactors do. Now, typically they've been big. You make them big because the economics of making things big makes it cheaper, until fairly recently. But there are, in fact, nuclear batteries that you can make where you make that core very much smaller, more along the scale of this or even smaller, and you can get energy out of it. And because the energy comes from this very, very small amount of matter, those batteries can be quite small. So in Canada, where they have a lot of ice to the north and very low density of population, they currently have diesel electricity generation. They fly the diesel in with helicopters. So you can imagine how expensive that electricity is if you're flying in diesel in the helicopters to keep the communities with electricity. So if you could put a nuclear battery in and you could run it for 4 or 5 years and have the same amount of power as comes out of those diesel gensets, that's entirely plausible. So there's a lot of work going into nuclear battery development, and Canada in particular is driving that. One of the reasons I'm interested in that is we don't have a cold place in Australia. We have a hot red centre with a low population density. And we've got some people on the gas grid, but we've got a lot of people with diesel gensets as well in that setting. And that's a future potential, I think, is that when they master the nuclear battery creation, would be to use those nuclear batteries even in our own rural and remote communities to get more reliable electricity. And then you use the same helicopters to pick them up and drop in a new one and take it away. Go for about 4 years, and it's a pretty efficient way of doing it. So there's big discussion in Canada at the moment about nuclear batteries, and a lot of discussion also about nuclear power in general and how important it is for Canada. Yeah, so that's an excellent question.
The reason why I asked that question is I bought a science magazine.
Yep.
Talking about the future, aircraft, you're going to use nuclear batteries to power an electric engine.
Yep.
And these aircraft are non-piloted.
Yep.
They jump over
Yep. So all of these things are really important ideas. At the moment, these probes that go out to Pluto and Saturn and all of those things, they use nuclear material, but they use it to generate a current. It's so, we wouldn't have been able to explore the outer reaches of our universe and our solar system without having access to these very clever nuclear technologies. And the dinky cart that runs around on Mars, the US one, that's got a little nuclear reactor in it as well. So, yeah.
Dr. Paterson, have there been any enlightening discoveries from the decay of the HIFAR reactor?
All right, yeah. Excellent. So HIFAR was our first reactor. It really operated into its 59th year and was decommissioned before Opal came on stream. The HIFAR reactor was a very different type of reactor. It wasn't a pool reactor, and it operated on different principles. It started life as a materials testing reactor. It finished its life as a neutron scattering and nuclear medicine reactor, so it changed right through its life. So we're busy preparing to fully decommission the HIFAR reactor. And one of the wonderful things is one of our very inventive scientists has developed a new technique to look into what is left of the reactor. The core's been removed, but there's still a lot of radioactivity in the area where the core was. And he's developed a very clever device that allows us to actually see where all that radioactivity is. That simple invention is going to take millions of dollars out of the cost of decommissioning that reactor. And in fact, that particular invention, there was a competition in France recently with all of the best people in the world to look for people who are hiding radiation in containers. And the only device that found all of the stuff that the guys were hiding in the containers was the one that was invented here at Lucas Heights by one of our really bright scientists. So you've got to know where it is.
We've got time for one more question, Tim.
How do your beliefs in science in regards to the age of the world, Big Bang Theory, dinosaurs coexist with what the Bible has to say?
Yeah, I think that's a great question. We can, if I don't satisfactorily answer that, I'm happy to have a scrum afterwards, and anybody's interested in that question, we can talk about it. Yeah, it would be a scrum. The only thing that Aussies and Australians agree about in rugby is that we must beat the All Blacks. Right? Yeah. So how does this work? All right. So my understanding of the Bible, and I've done a little bit of theology study myself, and in fact, one of my hobbies is reading about the Bible. My favorite book is John's Gospel, and I've read deeply about that and so on. But I've also been very interested in the debate about creation and when it happened and so on, and been involved in that debate really since I was a student. And my view is that the Bible is the book that brings us to life through salvation in Jesus. And to ask it to do more than that, which is everything we need, is not necessarily a good thing to do. As I said, in the Bible, of the 92 elements that we have in the periodic table before the ones that we made ourselves, only about 8 are mentioned. So you couldn't read the Bible and find all the elements of the periodic table, for example. So science adds to what we knew at the time people were writing out of their experience. And my belief is that the creation narrative teaches us 3 things. It teaches us, first of all, that this universe was brought into being with a spoken word, a word that was spoken by a being who could, by speaking it, bring it into existence. And that, to me, I absolutely am committed to. The second thing is that creation has order. It has a structure that is actually discernible even to the people who were writing at that time. They could see that order and that structure in that creation. And Psalm 19, for example, is just one of the most beautiful psalms. I've spent years and years just trying to understand what that psalm means. Is a story that captures the beauty of understanding how this order came into being. So there is some sort of science in Scripture, but it isn't a scientific textbook, not by any stretch of the imagination. I mean, when I was studying chemistry, there were 800,000 compounds. There's now of the order of 40 million described compounds. We are learning about stuff all the time, and that knowledge is accelerating. So The first thing is there's a spoken word. Second thing, that there's order. The third thing is that there are beings, the creation of man, woman, beginning of chapter 2, there are beings who will populate this place, who will be able to know God, and God will know them. And when that's at its best, it's like walking in the garden in the cool of the day and conversing and loving and encountering this God. And that's what the creation story teaches me. It teaches me that I can know God, that He has made an ordered world, and that He started it all. If I try and make it more than that, and I try and do genealogies and stuff like that, it really, I don't think that adds that. So I think the universe started between 13.9 and 14.1 billion years ago. I think that God started it then by speaking a word, as it says in the Bible. I believe that He's given it great order. That's why I was explaining gold. You know, it's just amazing that we can use equations to explain the temperature at which mercury becomes a liquid to a precision of about 1/10 of a degree. That to me is awesome. It says it's ordered. But the thing that that creation story says to me is that God wants to be in relationship with His creation. And He wants to be in relationship with His creation in a way that is essentially a paradise. And that's what the last book of the Bible and the last chapter of the last book of the Bible is all about. It's about the reestablishment of that beautiful created order which has suffered destruction. And so for me, I'm prepared to debate about what it is. The one thing I can tell you is that the vast majority of scientists, if we had them all in a row here and there were 100 scientists representing all the scientists in the world, probably 1.5 of them would be really cross about the Bible. The rest are just getting on with the science. And a lot of that science is making this a better place to be. And so there isn't a conspiracy from science to attack the Bible. There are a small number of atheists who really don't like the Bible, who represent that. I'm happy to have a chat on the side about that. I've got strong views on whether atheists are helpful or not. But, you know, my overall impression of the reading of the Bible is that God wants us to bring Jesus to life in the minds of people through the preaching of Scripture. And that includes knowing that it had a beginning, that it's an ordered beginning, and that there are people who walk in the garden with God and they don't get it right. And so Jesus came to make it right. And that has been a successful operation. That's what I believe.
Thank you, Adi.
Great.